Continuing on with how we would measure BOD in practice, we're going to go through a practical example, and I think it'll make a lot more sense once we're finished. So we've got our BOD bottle. We mentioned in our previous video that we would have our various samples, so our negative control, just pure water, our pure wastewater or wastewater effluent, our various dilutions. They start off maybe that way. You want to make sure that they're mixed. And then to measure BOD, we have to determine the initial DO values at like time 0, and then 5 days of full days after we determine again. So the change in the DO is what we're measuring. So here's just an example of a DO probe. There are a variety of different types that are out there. There are even instruments that kind of automate all this. So you measure your initial dissolved oxygen in each of your samples, including your negative control. You incubate for 5 days, and then you measure after the 5 days. BOD can be determined. There are a variety of formulas. This one's the easiest one. Usually we're using 300 milliliter BOD bottles. So we take the difference in our starting DO from our 5-day DO, multiply by 300, and divide that by whatever sample volume we used. For example, if we had a 30 milliliter sample volume, 300 divided by 30, that's a 10-fold dilution. The math would work out. So we'll go through an example here. Now, there are some rules in determining how to actually get your final BOD bottle. The control bottle should not change much. If it changes more than 0.2 milliliters, the test is supposed to be invalid. And then our sample bottles, they need to make a change. So the actual bottles that have like effluent in it or have the diluted effluent, they need to also have at least 0.2 milliliters of change, and there should be at least 1.0 milliliters of DO left in the bottle, because the meters have some variability and some noise in them, and once you start getting near 0, it may be your meter, not your actual DO. And then if none of the samples are within range, is a problem. And if you've got multiple samples within range, you can average them. They do this because measuring BOD is required in many cases by law. It's part of an NPDES permit, and typically you need to be able to measure the BOD values in the event that they are, exceeding 30 milligrams per liter, which would exceed your permit. You have to be able to show your state that your effluent that's going out to the receiving water is meeting the standards. And there are a variety of standards on the NPDES permit. Many states have switched this to E. coli, 200 E. coli per 100 mils. They also have a BOD value, total suspended solids, and the pH. Getting at actually doing the measurement in practice, we've got our mixed samples here. So our 300 milliliters of just pure water, our pure effluent sample, or in the event you were testing the wastewater coming in, so our influent or effluent, it don't matter. Then you're going to have your dilution of that, and then another dilution of that. This dilution again was 50 milliliters of that plus 250 milliliters of clean water, and this one's 30 milliliters of that and 270 milliliters of clean water. You'll collect your initial results, and then 5 days later, you'll collect your results again. Then you'll plug those results into the formula. So here we've got our initial results presented, 8.0 in our pure wastewater. The DO in our blank was 8.9. Our 30 milliliter one had an 8.3 when we took the DO probe and stuck it in there. This one had 8.4. After 5 days, here's what we got. This one went from 8 all the way down to essentially 0. It may be 0. It could be the meter is bouncing around up and down at 0. This one went from 8.4 to 4.2. This one went from 8.3 to 6.0. This one went from 8.9 to 8.8. So the first question we have to ask ourselves is, are all of our samples complying with those previous rules? So one of them is obviously more than 1. I mean, not more than 1. One of them is obviously less than like 1.0. So this one can't be used. Can't be used because it's below the value of 1. It could be background noise on the instrument. It could be 0. It likely is 0. We've likely exhausted all the oxygen. So that one can't be used. The next one, let's go over to the end over here. Did our blank change by more than 0.2 of a milligram per liter? Is it like 8.6, 8.5, 8.0? No. So our blank did not change much, which is a good thing. So since it didn't change by more than 0.2, it passes the test. And then these, they've changed our actual samples. They've changed more than 0.2, which is good. And they've also kept values that are greater than 1.0. So that one's good and that one's good. So now we can actually measure the BOD. So we measure the BOD5 in the samples that have reliable measurements. We don't measure it in here because that's not acceptable, because obviously it was below 1.0. So this one we measure, and then we can also measure that one. So when we measure this one, we see it's 8.4 minus 4.2, which this equals 4.2, and 4.2 times 300 divided by 50 equals 25.2 milligrams per liter of dissolved oxygen demand, or biological oxygen, or biochemical oxygen demand after 5 days. Here we go with this one, 8.3 minus 6.0, so the oxygen changed by 3.3 milligrams per liter, so that's how much demand was in that bottle. This bottle is been a 300 over 30 milliliter dilution, right? So 3.3 times 300 divided by 30 gives us 23. So to calculate our BOD5, what we have to do is we can average the 23 that we just got and the 25.2 that we got in the other one, and then we can estimate our BOD5 to being 24.1. All right, so we do this because we need to be able to take our water samples for complying with the law, which requires testing. And if we have a sample like this one, obviously the amount of wastewater here exceeds 7.9 or 8.0 milligrams per liter. That's the most you can get with pure wastewater. So we can't use that kind of analysis. We have to use the dilutions. And we do this so that we can comply with the law, and we need to make sure that our sewage treatment processes are working. So we're going to go over our sewage treatment processes here in the next video. So hopefully that was informative. BOD is something that industrial wastewater plants deal with. It's something that, as a professor, when I have former students that often call me about problems or challenges that they have going on, they often are asking about like BOD. You can't just measure BOD with a probe. You have to give it some time in most places or most settings. There are some processes out there to try to speed this stuff up, but overall, it's a pretty easy concept once you practice it. So I'm going to stop the video here, and we'll continue on with actually the steps in wastewater treatment.